Hi, guys. I hope you're having a wonderful week. We're going to continue with statistics. So, we're going to be introducing some new vocabulary, but most of today is about how to use the calculator in order to calculate a bunch of statistical data and analyze that information. I'm going to be showing you how to use this with a TI-84. So that's this kind of, but it's all the same buttons. I'm also going to be showing you how to do it with the Delta Math calculator, which is just like the TI-84. It just looks a little different. So the first thing is some information. Some of this you may know, some you may not. If you don't know it, write it down. You do have to post your notes this week. So to enter a table of data, that's right here. I'm going to go over how to do that. So if you want to pause it, write that down. To write a regression. So this is everything for how to use the graphing calculator for statistics. One thing to check is at the beginning when you get your calculator, go to Stat Diagnostic, click on Mode, go to Stat Diagnostic and make sure it's on. Okay, and just hit the on, enter, and you'll be good. All right, so this is how to enter a table of data. Over here is how to write a regression equation. We're going to come back to this later, but if you don't know how to do that, you would definitely want to write these notes down. You can pause it, write them down. I can move this right here. There we go. So that would be a good pause. Okay. On this side right over here, this determines which type of regression is the best fit. So for example, if you have a scatter plot and a bunch of points representing data that you've been gathering, maybe the temperatures, or maybe looking at different data about how many people are going out without masks on right now, you would calculate or plot all of that data, and then you'd want to see what a linear, straight line, an exponential, a quadratic, what would be the best model for this data. So the way you do that is you're going to create each type of equation using the steps that it says right here. So a linear, linreg, linear regression, quadratic, quadrag, quadratic regression, an exponential, xreg, and you're going to look at the R. The R is the correlation coefficient. You may remember that from ninth grade algebra when you did statistics. And the correlation coefficient tells you if you have a scatter plot with a bunch of points and the line of best fit that goes through the middle, how close are those points to the line? If they're really close, it's a strong correlation. So the R value is going to be really close to 1 or -1. If it's weak, it's going to be really scattered out. That means that there's not a strong correlation between the two things. That would be a lower R value like 0.5 or 0.6. Here, you can see with an exponential right on this side and a linear right over here, the R value for the exponential was 0.9994, whereas for the linear it was 0.8320. Therefore, the exponential regression is a better fit, and so you would write that equation. This last part is the most important part, so you definitely want to take notes on this, okay? All of this information down here is really important. Okay, the first one, normal CDF, we're going to come back to this. And this tells us the probability of percentage that data falls within two values. And we're going to learn what the heck that means. And the next is finding all the things that you know from middle school. Mean, median. If you remember lower quartile, upper quartile, that's the box and whisker plot. We'll review that as well. And you're also going to be learning about standard deviation. So today is just about learning the calculator. So write this all down. This vocabulary right here is going to be the crux of everything we do today. So please write this down carefully. And then this is the steps for how to use the calculator to get the data. I'm going to show it to you, but you want to pause and write this down. Now I'm going to show you. So I'm going to do a Delta Math example. The first section that you have is just using the vocab that you just wrote down, seeing what it's asking for, and finding that. So it's just identifying the vocabulary. That's it. Nice and easy. Okay. Measures of dispersion. So the first way I'm going to show you how to do it with the calculator in Delta Math. So what's awesome is that it copies everything for you. The first thing you want to do is you want to copy all of this data. So we can just hit copy values for calculator and then open statistics calculator. And it popped up right here. Now you can go through and you can type in every single number that you see here and type them in here. Or we can do the cheater way and just hit paste values. And the computer does it for us. So thank Zach for Delta Math that he did that. So the first thing is just entering the data. Next thing we're going to do is calculate. So instead of edit list, we're now going to go to the calculate menu. In the submenu under calculate, we're going to be choosing one variable statistics. The reason why is because frequency means how often this happens. So it means that you would have 4 written out 9 times, 5 written out 9 times, 6 written out 3 times, etc. Instead of us writing 4, 4, 4, 4, 4, 5, 5, 5, 5, 5, this is a quicker way of doing it. So we have to tell the calculator it's still one variable statistics. It's only this one piece of data that we have. But we also have a frequency list. So our frequency list, if you look at the name of it over here, in the edit, is L2. That's the frequency list right there. So in my calc, I'm going to put L2 for the frequency list. And then I hit calculate. And it gives me all of that data. And then you're going to just find what it needs. Okay. So it's pretty straightforward. It's just about learning how to use the calculator. Next thing I'm going to show you how to do is do it in the graphic calculator. Sorry. Okay. Move this. Give up. Get a new problem. Don't hit give up. Remember that I'm taking points off for people who hit give up over and over. Okay, so here's a new problem. So in the calculator, we're going to go to Stat, Edit, and if there's anything there, you just hit delete and just delete those. Don't hit clear. Okay, so for under L1, I'm going to type in all the data I have. That was 18. The next one is 20. The next is 21, 27, 28, 29, 31, 33. And then I go over to my L2, and it's 5, 6, 9, 5. And I'm just going to check 27 is matched with 5. Good. 28 with 2, 29 with 7, 31 with 7, and 33 with 3. Okay. So that was under Stat and Edit, and we hit Enter. Okay, so it's going to stay there. Now I'm going to go to Stat again, because everything's in statistics, and see how it says Calc up here? I go over to Calc, just like I chose Calc on there, and I'm going to choose one var stats, one variable statistics. I hit Enter. I do have a frequency list, so the way I put L2, if I see it's in blue right above the 2, so I push the second button and then 2 for L2, and then I go to Calculate and I hit Enter. And again, it gives me all the same data, and I can just go scroll down to get all of it. Okay? Last thing I'm going to show you is what happens when there is no frequency list. So here's an example of a list. Okay? I'm going to use the Delta Math calculator. So I'm going to copy the values. There's no frequency list here, so remember that. I am going to paste the values. Notice they're only in list 1. There's nothing in list 2. So when I go to Calc and I go to one variable statistics, I'm leaving this blank because there's no frequency. I hit Calculate, and again, it gives me that data. Okay. Now here, this is going to be a little bit different because we're going to do that first. Remember that this right here symbol is the mean. So that's the average. All of the data, that would be like the middle of what it is, kind of. So that's the average, the mean. Now it asks us, move my picture down, find the number of data within one population standard deviation. So I go back and I say, what's a population standard deviation? It's this symbol right there. Okay. So I'm going to go here and I look at that right there. And that means that I'm going to go from 57.5 and I'm going to go up this many and down that many. So what that means is I take the average, I'm going to add the standard deviation, okay? And then I'm going to subtract the standard deviation. Since it says within one standard deviation, I'm looking one above and one below. So if I go back to my original problem, right, the average was 57.5, okay? And the population standard deviation was 4.153. So I'm going to add 57.5 plus 4.153. And then I'm going to do 57.5 and subtract 4.153. So that's going one above and one below. That gives me 53.347 up until 61.65. So I go back to my data and I say, which of these are between 53.3 and 61.6? So this is not, but this one is. So that's 1, 2, 3, nope, 4, and 5. So 5 out of 1, 2, 3, 4, 5, 6, 7, 8. So it says the number of data, so the answer would be 5. If it said the percentage of data, I would do 5 divided by 8 and then turn that into a percent by multiplying by 100. Okay, so just look at the example if you get stuck on these ones to follow how to do it. Pay attention to the number of population standard deviations you're going to go, and if you're finding the percentage or the number of data. Number of data just means how many of these numbers that you see here are within that range, okay? One above and one below. That's it for this week. It's all about the vocab, all about learning what these different symbols mean, okay? So make sure to take good notes, post the notes, there's no work to post for this. Have fun.